part C. The angle 2 theta between the legs of the ladder is 60 degrees, and the cross tie bar is 1/3 the way down the leg. Okay, so that is a third, that's 2/3. 60 degrees. Calculate the maximum tension in the cross tie bar when the electrician has a mass of 70 kilos. The legs are 3 meters long. We've just worked out what the tension is. So mg we would know. H is going to change as the guy walks up and down the ladder. I guess that's why they're asking for the maximum one. Tan theta we would know if we know theta. L cos theta take D, we know everything. Therefore, the maximum one we can just go for. So max tension is when H is largest, because everything else is going to stay the same. And H will be, how high can you go? Well, you can go L cosine theta. So you've got T max equals mg h mg L cosine theta, that's H, tan theta over 2 L cosine theta, take D. So cos theta times tan sine over cos, so this is just sine theta. So mg L sine theta over 2 L cosine theta, take D. Now we're told 2 theta is 60 degrees, so theta equals 30. L equals 3 meters. M is 70 kilograms. G is obviously 9.81 meters per second squared. D is what we need, which is that height there, which is going to be 2/3 of that height. So it's 2/3 of L cos theta. And D is 2/3 L cosine theta. Okay, well that makes it easy. L cosine theta minus 2/3 of L cosine theta is just 1/3 of L cosine theta. So we've got mg L sine theta over 2 times 1/3 of L cosine theta. Goodbye L's. So that's going to be 3 over 2 mg tan theta, 3 over 2, 70 kilograms times 9.81 meters per second squared times 10 of 30. Just looking at the units. This is going to be a force, and of course mg is a force. Tan theta is dimensionless, so that works out. So 3 divided by 2 times 70 times 9.81 times 30. Make sure my calculator's in degrees mode. It is 0.58. That doesn't sound like a big tension. What have I done wrong? That's clearly not 0.58, is it? Let's try that again. 70 times 10, that's... Always check. 1070 times 9.81 times 30. 0.5 item plus equals 0.58, of course, is 10 and 30. 595 newtons, significant figures. Assume everything to be in one significant figure here, 600 newtons. Seems about reasonable, doesn't it? The guy's weight is going to be about 700 newtons. Something of that order seems reasonable. 2. C part 2. Explain what effect increasing the angle will have on this maximum tension, assuming the cross tie bar remains fixed to the same points on the ladder. So if we increase theta, this is where we are. So if we increase theta, tan theta goes up, so we have an increased tension. So theta. So if theta increases, tan theta increases. So that obviously implies T increases, or the maximum tension. Tan theta. So what I'm doing, I'm just thinking, what can we physically take this to the extreme now? So theta equals 0. So theta that way. 0, tan theta is 0. At 90 degrees, tan theta goes off to infinity. So at 0 angle, there is 0 tension in the tie bar, which kind of makes sense because everything is going directly down the legs. Of course, it's a rather unstable ladder, but there we go. So as theta goes to 90 degrees, though, tan theta goes to infinity, and so you get infinite tension. So if you have a ladder, which is kind of like that, with a tie bar across there, and you're standing or standing in the middle, you've got some extreme tension in there. Which is basically the reason why you don't have ladders like that.